So last class we were discussed about definition of a matrix, order of a matrix, types of matrices, and operations on matrices, in which we are discussed addition of a matrices, scalar multiplication of a matrices, and transpose of a matrices. Today, let us continue with the multiplication of matrices. How to multiply two matrices? Multiplication of matrices. To multiply two matrices A and B, we need some condition. That condition is, in the first matrix we should have number of columns must be equal to, in B matrix, number of rows. To have a multiplication of matrices, we should have number of columns of first matrix must be equal to number of rows of second matrix. Then only multiplication is possible. It is not as simple as addition and subtraction. In that way, we take corresponding elements. Here it is not that type. We should have columns of first matrix must be rows of second matrix. Then only multiplication is possible. After multiplication, we get another matrix, that is AB. AB is what? It is a matrix which is obtained after multiplication of A and B, whose order is always equal to number of rows of A into number of columns of B. This is the condition. See this equation. Suppose A is a matrix of order M cross P. Let us take another matrix, that is B, whose order is equal to P cross N. Then we get their product as AB. A into B, whose order is always equal to number of rows of A, number of columns of B, that is M into N. See, the first matrix is having P number of columns, the second matrix is having P number of rows, then they are same, multiplication is possible. Okay, to multiply the matrices, we should follow rows into columns. Rows into columns. Rows into columns. Okay. I will show an example. Take two matrices A and B. A and B. Multiplication of A and B is always equal to like this. First row into first column. The entire row should be multiplied with the entire column. Then we should go for first row into next column, that is second column, first row, third column, and so on. After multiplying a first row with all the columns, we need to move to the second row. That second row is multiplied with first column, second row is multiplied with second column, second row is multiplied with the third column, and this will go on. And if there is a third row, we should take that third row and which is multiplied with all the columns. Third row, first column, third row, second column, third row, third column, and this will continue. This is the process of multiplication. Right? Note this point. A, B is not at all B equal to B AB old transpose is always equal to B transpose into A transpose. Let us take a square matrix A and producted with the unit matrix of same order. It is always getting A only. Here A and I are having same order square matrices, right? These are some of the notes. Let us take an example of multiplication. If A is equal to 5 minus 3, 2, 1 and B is equal to 4, 6, 3 minus 4. Find AB. Write AB 5 minus 3, 2, 1 into B 4, 6, 3 minus 4. So multiplication is a process of multiplying the entire row with entire column. See, you take first row, how many elements are there? 2 elements. Take the first column, how many elements are there? 2 elements. Then start multiplying. First element of first row into first element of first column. That gives you 5 into 4 plus of move forward along the row, here move down along the column. That is second element of first row is multiplied with second element of first column. That is minus 3 into 3. Minus 3 into 3. So this entire thing becomes a single element in the answer. I repeat it. See, the first row is multiplied with first column. How it is? First element into first. 5 into 4 plus minus 3 into 3. The row is multiplied with column. One step is over. Then we have to move with the same row and second column, right? 5 into 6. 5 into 6 plus move to the next element. Here move to the down next element of the column. Minus 3 into minus 4. Minus 3 into minus 4. First row is multiplied with all the columns. Then we should move to the second row. Which is second row? 2, 1. Which is multiplied with all the columns. Let us take first column. Second row, first column. 2 into 4. Plus move ahead here, move forward, here move down. 1 into 3. 1 into 3. Next, second row, second column. 2 into 6 plus 1 into minus 4. This is the procedure to have a multiplication. Then just to simplify this, 5 into 4, it is 20, plus into minus, 3 3s are 9, 5 into 6, 30. Here we have minus 2 minuses in the bracket, multiply them, minus into minus plus. Then with the plus into plus is plus. 3 4s are 12. 4 2s are 8 plus 1 into 3, 3. 2 into 6, 12 plus into minus 1 into 4 is 4. 20 minus 9, it is 11. 30 plus 12, it is 40. 2. 8 plus 3, it is 11. 12 minus 4, it is 8. This is A plus B. We got the multiplication. It is what? It is row into column. One row is taken, which is multiplied with all the columns. The next row is taken, which is multiplied with all the columns. Further, we need to simplify it. Let us do different problems one by one. If A is equal to 5 minus 4, 3, and B is equal to 1, 3, minus 5. Show that AB is not equal to BA. Let us first find out left hand side. What is left hand side? It is AB. What is A? 5 minus 4, 3. What is B? 1, 3 minus 5. What is multiplication of two matrices? It is rows into column. First row. So we have only one row. First column. We have only one column. If we multiply with this row with this column, the entire procedure will be over. That is because we have only one row here. Here only one column will be there. Therefore 5 into 1. 5 minus 4 into 3, that is minus 12, plus into minus 3 5s are 15. Finally, the answer is 5 minus 12 minus 15. Difference between these two is 10, minus 10, minus 10, minus 12, minus 20. See, the first matrix row. How many rows are there? 1. How many columns are there? 3. Second matrix. How many rows are there? 1, 2, 3. 3 rows. How many columns are there? Only 1 column. First matrix is having 3 columns. Second matrix is having 3 rows. So multiplication is done. What is the order of the end matrix? Column, rows of first into columns of second. See, this is 1 into 1. Next, let us do BA. What is B? It is a column matrix, right? We have only one column. 1, 3 minus 5. A. What is A? It is a row matrix. 5 minus 4, 3. Multiplication is nothing but rows into column. Check this. First row, first column. How many elements are there in first row? We have only one element. How many elements are there in first column? Only one. So this element into this element will be the first row into first column. That is 1 into 5. The first row is multiplied with first column. Right? Next, we have to move to the second column with the first row. First row, second column. First row is one element. Second column is only one element. Then 1 into minus 4 is minus 4. Which is second element in the first row of answer. First row, third column, that is 1 into 3, that is 3. We multiplied a first row with all the columns. Then we should move to the second row. Second row, first column, that is 3 into 5, 15. 3 into minus 4, that is second row, second column, minus 12. Second row, third column, that is 3 into 3, 9. Second row is multiplied with all the columns. Then we should move to the third row. Third row is minus 5. First column is 5, minus 5 into 5, minus 25. Third row, second column, minus 5 into minus 4, that is minus into minus plus, 5 4 is 20. Third row, third column, minus 5 into 3 is minus 15. See, AB is a single element, whereas BA is having 3 rows and 3 columns. Hence, we can say that AB is not at all be equal to BA. Right? Then, let us move to the next problem. If A is equal to 1, 3, minus 2, 4, 1, 5, and B is equal to 6, minus 3, 2, minus 1, 1, 4. Show that A, B whole transpose is equal to B transpose into A transpose. The question is what? They are given two different matrices. With that, we need to show that AB whole transpose is equal to B transpose into A transpose. I will take first AB. Do AB first. A into B. What is A? 1, 3, minus 2. 4, 1, 5. What is B? B is 6, minus 3. 2, minus 1. 1, 4. What is multiplication of matrices? It is rows into column, right? You take first row is multiplied with the first column. In first row, how many elements are there? 3. In first column, how many elements are there? 3. So multiply each 1. 1 into 6, 6. Then move to next element 3. 3 into 2 plus 3 into 2 is 6. Here, third element is minus 1. In the column, third element is 1. Multiply them. Minus 2 into 1 is minus 2. This is first row, first column. Okay. Next, first row, second column. 1 into minus 3 is minus 3. Next element, 3. Here, down. Next element is minus 1. 3 into minus 1 is minus 3. Minus 2 into 4, that is minus 8. First row is multiplied with first column and second column. Then we should take the second row, which is multiplied with what? First column and second column. 6 4 is 24. 1 into 2 plus 2. 5 into 1 plus 5. This is second row, first column. Then second row, second column. 4 into minus 3 minus 12. 1 into minus 1 minus 1. 5 into 4, 20. Just write the simplified answer. 6 plus 6, 12. 12 minus 2 is 10. Minus 3, minus 3, minus 8. Minus 6, minus 8 is minus 14. 24, 26, 31. Minus 12, minus 1, minus 13. Minus 13 plus 20 is 7. So therefore, left hand side is equal to what? AB whole transpose. First I calculated AB, then I am doing AB whole transpose. Transpose means what? It is changing rows into column, right? Make first row into first column, that is 10 minus 14. 31, it is 7. It is what? It is the left hand side of the property. Then we need to find out B transpose into A transpose. What is B? B is B transpose into A transpose. Right. B transpose. B is 6 minus 3, 2 minus 1, 1 4. Make first row into first column is what? 6 minus 3. Second row into second column, 2 minus 1. 1 minus 1, 4. Why I am doing this? I need B transpose. Just I am transposing it. Okay. Next, A transpose. What is A transpose? 1, 3 minus 2. First row is made as first column. Second row, 4, 1, 5 is made as second column. Right? Then multiply. What is multiplication? It is rows into column. Okay. See, first row, which is multiplied with first column, 6 into 1, 6. Move to the next element in the row. Here, move to the next element in the column. That is, multiply them. 2 into 3, 6. Add it. Then third element is what? 1. Here third element is what? Minus 2. 1 into minus 2 is minus 2. The first row is multiplied with first column. Okay. Next, first row is multiplied with second column. 6 into 4, 24 plus 2 into 1, 2 plus 1 into 5, 5. Next, second row, first column, minus 3 into 1, minus 3, minus 1 into 3, minus 3, 4 into minus 2, minus 8. Second row, second column, minus 3 into 4, minus 12, minus 1 into 1, minus 1, plus 4 into 5, 30. Then 6 plus 6, 12. 12 minus 2 is 10. 24, 26 plus 5, 31. Minus 3, minus 3, minus 6, minus 8 is minus 14. 13 plus 20 is 7. See, left hand side is what? It is 10, 31 first row, minus 14, 7 is second row. Here also we have 10, 31 is first row, minus 14, 7 is the second row. Are one and the same. Right, it is verified. That is A, B, old transpose is always equal to B transpose into A transpose. Okay. Then, next problem. If A is equal to 3, 3, 3. All elements are 3 only. 3, 3, 3. Show that A square is equal to 9A. A square is equal to 9A. A square means what? It is not squaring all the elements. It is a multiplication of two matrices. It means we have to go according to rows into column only. Don't square each element, right? A square is equal to A into A. Right? A twice. 3, 3, 3. All elements are 3 only. 3, 3, 3 into again same matrix. 3, 3, 3. We go rows into column. First row is what? All elements are 3, 3. In the second matrix, first column is what? There also we have 3, 3, 3. Their product become what? 6. First row, first column. 3 into 3, 9. Plus 3 into 3, 9. Plus 3 into 3, 9. 9 plus 9 plus 9. It is what? A square is equal to 9 plus 9 plus 9. This is first row, first column. Like that. If I take second row, first row with the second column, I am getting same thing. 3 into 3, 9 plus 3 into 3, 9 plus 3 into 3, 9. So here also all the elements are 9 plus 9 plus 9. First row, third column, 9 plus 9 plus 9. 9 plus 9 plus 9. See, all elements are identical in both the matrices. The product is always getting same. See, 9 plus 9 plus 9, 9 plus 9, 9 plus 9 plus 9. It is also 9, 9, 9, 9 plus 9 plus 9. So answer is what? 9 plus 9, 18 plus 9, 27. 27, 27, 27, 27. All elements are equal to 27. So I can prove it in two ways. So one, I take 9 common from all the elements. So if I take 27 as 9 into 3, 9 into 3, 9 into 3, 9 will be common in all the elements that can be taken outside. That becomes what? 9 into 3, 3, 3. What is 3, 3? It is a. In other words, I can prove it in other way. So A square is what? I will be taking as right hand side. What is, left hand side. What is right hand side? Right hand side is 9A. Just I will make scalar multiplication. 9 into A, 3, 3, 3. So I am getting same answer. 9 into 3, 27, 27, 27. So we got both are same. That is A square is always equal to 9 into A for a given matrix. Okay. In the multiplication, we can also, using multiplication, you can also find an expression value. Here, multiplication, addition, and subtraction will also be there. If A is equal to, I will take 2 cross 2 matrix. 2 minus 1, 3, 5. Then find a square minus 5a plus 9i. I is what? I is the unit matrix or identity matrix. To get this equation value or expression value, I need to find a square. I need to find 5a, then I need to find 9i. Okay. Let us find out one by one. A square is what? A into A. Don't square each element. 2 minus 1, 3, 5. A. One more A. 2 minus 1, 3, 5. Take that product. What is it? It is rows into column. First row into first column. 2 into 2. 4 minus 1 into 3. Minus 3. First row, second column. 2 into minus 1. Minus 2, minus 5, minus 1 into 5, minus 5. First row is multiplied with first column, first row is multiplied with second column. Then move to the next row, second row into first column. 3 2s are 6, 5 into 3, plus 15. 3 into minus 1, minus 3, plus 25. It is 4 minus 3 is 1. Minus 2 minus 5 is minus 7. 6 plus 15, it is 21. Minus 3 plus 25 is 22. This is what? A square. Then what I need? I need 5a. 5 into a. 5 into. What is a? 2 minus 1, 3, 5. Multiply all the elements of matrix with 5, that is scalar multiplication. 5 into 2, 10, 5 into minus 1, minus 5, 5 3s are 15, 5 5s are 25. Then I need 9i, 9, what is I? I is identity matrix 1 0 0 1, that is equal to 9 0 0 9. Take all these values and substitute in the given equation. What is that equation? A square minus 5a plus 9i. The equation is a square minus 5a plus 9i. That is equal to a square 1 minus 7 21 22 minus 5a. 5a is what? 10 minus 5, 15, 25. 10 minus 5, 15, 25 plus 9i, that is 9 0 0 9. Next thing is you have to take subtraction of these two, then we have to add this. So you do it simultaneously. Take all the elements along with the sign, that is 1 minus 10 plus 9. 1 minus 10 plus 9. Next, second element of first row, minus 7 minus of minus 5 plus 0. Minus 7 minus into minus plus 5 plus 0. 21 minus 15 plus 0. Last element 22 minus 25 plus 9. So finally we get 1 plus 9, 10. 10 minus 10 is 0. Minus 5, sorry, minus 7 plus 5, it is minus 2. 21 minus 15, it is 6. 22 minus 25, it is minus 3. Minus 3 plus 9, it is 6. This is the expression value. It is found using the given matrix A, right? Let us take one more example. If x1 0 0 y minus z 3 0 z into 1 pi minus 3 is equal to 7 minus 4 2. Find the values of x, y and z. So here they have given three matrices. At the left side we have two matrices which are in product, which is equal to a column matrix. To simplify for x, y, z, first we need to multiply these two. Left hand side matrices are to be multiplied. What is multiplication? It is rows into column. First row, first column. Second matrix is having only one column, hence row into column, hence the multiplication in the first step. That is x into 1, 1x, plus 1 into 5, plus 5, plus 0 into 3, 0, plus 0, minus 0. So first row is multiplied with first column. Then move to the second row. 0 into 1, 0, y into 5, plus 5y, minus z into minus 3, it is plus 3z. Second row is multiplied with the column. Next third row, 3 into 1, it is 3, 0 into 5 plus 0, z into minus 3, it is minus 3z, is equal to what? It is a column matrix of 7 minus 4, 2. 7 minus 4, 2. So according to equal matrices, what is meaning of equal matrices? When two matrices are said to be equal, they should have same order and the corresponding elements also same. Using that concept, this is a single element which is equated to 7, means x plus 5 is equal to 7. This is a single element. 0 plus 5y plus 3z is equal to minus 4. Minus 4. 3 plus 0 minus 3z is equal to 2. From these three equations, we have to get the values of x, y, z. See the first equation. Here we have only one unknown, that is x, that can be found directly. X is equal to 7 minus 5, that is x is equal to 2. In the second equation, there are two unknowns, y and z, both are unknown. So here we know x, we don't know y and z to calculate these. If I go to the third equation, here also we have only one unknown, that is z minus 3z is equal to 2. When 3 is transferred to the right side, whose sign will changes, it is minus 3. Minus 3z is equal to minus 1. Therefore, z is equal to minus 1 by minus 3, or it is 1 by 3. From this z, we can get the value of y. Just substitute the value of z in the second equation. Then we will get y. 5y plus, what is z? Z is equal to 3 into 1 by 3 is equal to minus 4. So these 3 get cancelled. The remaining is what? 5y plus 1 is equal to minus 4. Or 5y is equal to minus 4. Transfer 1 to right side, its sign changes, it becomes minus 1. So 5y is equal to minus 5. Therefore, y is equal to minus 5 by 5, which is equal to minus 1. So in this way, we can get the values of unknown also. It has worked out, no problem of such type. If 3 minus 2 x into 1 4 minus 7 is equal to 12, find x. So at right side, see, we have the two matrices. First one is row matrix, second one is column matrix. By multiplying these two, you are getting 12. Then what is the value of x? You just multiply it, row into column. Only one step, row into column, because here we have only one row, here we have only one column. That is 3 into 1, 3. Minus 2 into 4, minus 8. X into minus 7, minus 7x. Multiplication is which is equal to what? 12. According to equal matrices, you just equate on both the side. 3 minus 8 is minus 5, minus 7x is equal to 12, or minus 7x is equal to 12. When minus 5 is transferred to the right side, it becomes plus 5. So minus 7x, which is equal to 17, or x is equal to 17 by minus 7. It is minus 17 by 7. So these are the some of the examples based on the multiplication, right? Next, let us define determinant. So matrix and determinant, they appears like same on just weaving it, but they are having different meaning. What is matrix? Matrix is a rectangular arrangement of numbers. So in which, if I take a square matrix means what? Rows are equal to column. To define determinant, I use the concept of square matrix. Each square matrix will have a unique value. Each square matrix will have a unique value. That unique value is said to be determinant of that square matrix. Determinant of that square matrix. Then I can define determinant as every square matrix will have a unique solution or unique number. That number will be called as determinant of that square matrix. This is denoted as determinant. Or suppose A is a square matrix, then I can write determinant of A. Or symbolically, I can write like this. I can write determinant of A. So this is the definition of determinant. Every square matrix have a unique value. So that unique value will be called as determinant of that matrix, right? Let us take a square matrix of order 1 cross 1. It is a matrix, right? For this matrix, if it is taken A is a square matrix. Order is what? 1 cross 1. Its unique value is 3, or we can write 3. 3 will be the determinant value of the matrix A. This is the definition of a matrix of order 1. So, if the square matrix is having order n cross n, which will be always having a determinant of order n only. In the same way, if I take a matrix 3, 2, 1, 5, then its determinant value is taken like this: 3, 2, 1, 5. This is the determinant of this square matrix. Its value is always equal to product of these two elements, principal diagonal element, that is 3 into 5. 3 into 5 minus product of secondary diagonal element, it is 1 into 2. 3 into 5 is 15 minus 1 into 2 is 2. That is equal to 13. So this 13 is the determinant value of this square matrix, right? In that way, we can have a determinant value of 3 cross 3 matrix, square matrix also. In simple way, I explain you. Determinant is a square arrangement of numbers. Square arrangement of numbers. See the example: A, B, X, Y. This is a determinant. A, B, C, X, Y, Z, P, Q, R. This is a determinant. Order of determinant always gives you the number of rows and number of columns. It will be called as determinant of second order. This will be called as determinant of third order. These elements will be called as principal diagonal elements. Okay. These elements are called as secondary diagonal elements. These are the principal diagonal elements. These are the secondary diagonal elements. You just remember this expansion of determinant. Number 1, let A, B, X, Y, A, B, X, Y be a determinant of order 2. Determinant of order 2. The value of this determinant is equal to determinant of A, or I can write like this. If it is a is equal to product of principal diagonal elements minus product of secondary diagonal elements. According to this, determinant A is equal to, which are the principal diagonal elements? A and Y. A into Y, that is AY, minus secondary diagonal elements B and X, their product is BX. Finally, you will get some constant. So that's why I told you earlier, every square matrix will have a unique value, that is a constant, right? It is the expansion of second order determinant. Let us take third order determinant and how it is to be expanded. Let A, B, C, X, Y, Z, P, Q, R be a third order determinant. It is a third order determinant, right? Expanding this determinant is determinant A is equal to, you take the first element plus minus plus. So this is according to this value minus 1 to the power of I plus j. I will be the row, j will be the column. See, minus 1 to the power of I plus j is what? This is what? First element in first row and first column. So 1 plus 1 is 2. That's why we will get what? Plus a into. Leave the corresponding columns of A and the corresponding rows of A. Remaining thing should be taken in the determinant value. Y, Z, Q, R. Y, Z, Q, R. Then minus of second element. Second element is what? B. Leave the column and row. What are the other elements left out? X, Z, P, R. X, Z, P, R. Plus third element of first row, C into. Leave the corresponding column and row. Remaining elements are X, Y, P, Q. Then it is A into. Expansion of second order determinant, it is similar to previous one. Product of principal diagonal elements minus product of secondary diagonal element. This is what? Y into R minus Q into Z. Z into Q. Minus B into product of these two. R into X minus product of these two. P into Z. Plus C into product of these two, Qx minus Py. See the expansion. Expansion of determinant is very important. I repeat you once again. To take the plus of first element of first row, A, leave the column and row, Y, Z. Remaining elements are what? Y, Z, Q, R. Minus of B, leave the corresponding column and corresponding row. What are the remaining elements? X, Z, P, R. Plus of C, C into, leave the corresponding columns and rows. What is the remaining? X, Y, P, Q. Then we have a second order determinant at the first step. Expanding. Product of these two, Y into R, YR minus Q into Z, QZ. Minus of B into product of these two, XR minus P into Z, PZ. Plus C into product of these two, X into Q, QX minus P into Y, PY. Finally, you will get some constant. This is expansion of a determinant, right? Let us take an example. The value of determinant. Number 1, 5 minus 3, 2, 7. 5 minus 3, 2, 7. It is product of these two is what? 5 into 7. Minus, it minus is what? It is a formula minus. Please remember it as a formula minus. Formula minus. Then multiply these two. After writing this formula minus, we have to go for multiplication of the secondary diagonal elements. That is minus 3 into 2. Minus 3 into 2. Okay. 5 into 7. 35 minus into minus plus 3 2s are 6. So according to the sign, you make simplification. 35 plus 6 is equal to what? 41. It is the determinant value, right? Check second one. 3 minus 5 minus 2, 7. Its value is equal to what? Do directly. Product of these two. 7 into 3 or 3 into 7. It is 21. Formula minus. Put the formula minus. Then multiply these two. Minus into minus plus. 5 to the 10. Plus 10. This is 21 minus 10 is equal to 11. 7, 2 minus 3 minus 1. What is the expansion of this? Product of these two. 7 into minus 1, which is minus 7, minus of. This is which minus? Formula minus. 2 into minus 3, which is equal to minus 6. So minus 7 minus into minus plus 6 is equal to minus 1. This is the way in which you have to get the value of second order determinant. You take third order determinant. 1 minus 5 minus 3, 2 1 minus 4, 1 6 minus 7. How to find out its value? As I mentioned earlier, you take alternatively plus minus plus for the first row elements. Along with that standard sign, you get the determinant value. Determinant is equal to plus of 1. Leave the corresponding column of first element. Remaining element taken in the determinant column. 1 minus 4, 6 minus 7. Minus of second element is what? Minus 5. This is again you can call them as minus is from formula side. Standard symbol. Minus 5. Leave the column and draw 2. 2 minus 4. 1 minus 7. Plus again it is formula plus what is element? Minus 3 into. Leave the corresponding column and row. 2 1 1 6. 2 1 1 6. Then expand it. 1 into minus 7. It is minus 7. Formula minus 4 into 6 is minus 24. Minus into minus plus 5 into 2 into minus 7. It is minus 14. Minus of formula minus 1 into minus 4 is minus 4. Plus into minus 3 into 2 into 6. Product of principal diagonal elements. It is 12 minus 1 into 1 is 1. Then it is 1. Minus into minus is what? Plus minus 7 plus 24. It is minus 7. It is equal to how much? 17. Minus 17 or plus 17? It is plus 17 because here I get minus 20, minus of minus plus 24. Plus 24 minus 7 is plus 17. Plus of 5 into minus into minus again plus. Minus 14 plus 4 is equal to minus 10. Minus 3 into 12 minus 1 is 11. That is equal to 1 into 17. 17 plus into minus 5 into 10, 50. Minus 1 into, 3 into 11 is 33. Only one is positive number, other two are negative number. You take the sum of the negative numbers. That is minus of 50, 33. It is 83. Finally, answer is minus of 13 minus 7 is 6. 7 minus 1 is 6. Minus 66. This is the value of determinant of order 3 cross 3. Right? I take one more example for this. So this expansion of determinant will come across in all the topics. Please work it out very carefully. Get the value of 3, minus 2, 1, 5, 3, 2, 1 minus 4, minus 5. So as I mentioned earlier, just put the standard symbols over the first row elements. That is, you take 3, leave the corresponding column and corresponding row. Remaining things are 3, 2, minus 4, minus 5. Minus of second element in the first row is what? Minus 2. Leave the corresponding elements of the element rows into column. Remaining is 5, 2, 5, 2, 1, minus 5. Plus of 1 into. Leave the corresponding column and row. Remaining is 5, 3, 5, 3, 1, minus 4. Then further expand the second order determinants. 3 into minus 5, minus 15, minus of, this is formula minus, multiply these two. Minus 4 into 2 is minus 8. Minus into minus, plus 2 into 5 into minus 5 is minus 25, minus formula minus 1 into 2 is 2, plus 1 into 5 into minus 4, minus 20, minus of 1 into 3 is 3. It is 3 into minus 15, minus into minus, plus 8, plus 2 into, both are negative sign, therefore number should be added and keeping minus sign as it is 27. Plus 1 into 20, minus 20, minus 3, again minus 23. We have to add the numbers because of having same sign. Minus 15 plus 8, it is minus 7. Minus 7 into 3, minus 21. Plus into minus, minus 27 into 2 is 54. 7 to the 14, 4, 1 carries, 2 into 2, 4 plus 1 is 5. Plus into minus, minus 23. So all elements are having negative sign. Alright, negative sign. Then add all the numbers. 3 plus 4, 7, 7 plus 1, 8. 2 plus 5, 7, 7 plus 2, 9. This is the value of determinant. So in the determinant, we discussed definition of determinant and how to expand a second order determinant and the third order determinant. Please work out more number of problems on expansion of a determinant, which will help you in all the chapters. It will be very useful in the other chapters, right? With this, I conclude today's class. The interaction,